According to the 2020 National Electrical Code, Section 680.26 BOEM, the area within 3 feet of the inside walls of the pool shall be considered as part of the pool and shall be subject to all the requirements applicable to the pool. Furthermore, 2020 NEC 680.26 states that metal parts of fixed or portable ladders, steps, and diving boards shall be bonded to the pool reinforcing steel. The concern regarding the boulders near the pool is valid. Even though the boulders are not specifically mentioned in the code as a walking surface, they are within the 3-foot bonding zone of the pool. They can reasonably be expected to be climbed on and touched while in the water. Therefore, it is prudent to extend the bonding grid under the boulders to ensure electrical safety. The boulders are essentially metal-containing objects and can conduct electricity like any other conductive material. While it is true that the code does not explicitly state that bonding is required under non-walking surfaces, the intent of the code is to ensure safety and prevent electrical hazards. Extending the bonding grid under the boulders is consistent with this intent and provides an added layer of protection. The boulders within the 3-foot bonding zone should be included in the bonding grid for the safety of pool users. It is advisable to discuss this further with the relevant parties and provide the rationale behind this decision. If necessary, clarification can be sought from the local authority having jurisdiction or lodge. The primary purpose of the bonding grid is to equalize the electrical potential in and around the pool area. This reduces the risk of electric shock to anyone in or near the water. When a fault occurs, such as a live wire coming into contact with a metal part near the pool, the bonding grid provides a low impedance path for the fault current to return to the source. This low impedance path facilitates the rapid tripping of the circuit breaker or ground fault circuit interrupter, or GFCI, protecting people from dangerous voltage levels. The 3-foot rule around the pool is a critical safety measure. It is based on the understanding that people are likely to be in close proximity to the pool's edge, either entering, exiting, or simply standing nearby. Any conductive objects within this zone need to be bonded to prevent voltage differences that could cause electric shock. Considering the composition of the boulders, which includes metal, the risk of electrical conductivity is real. Natural materials like rocks and soil can become conductive, especially when wet. Since the boulders are likely to be wet due to splashing or rain, they pose a potential electrical hazard. Even if the code doesn't explicitly mention boulders, it's important to interpret the code in a way that prioritizes safety. The intent of the code is to protect people from electrical hazards, and any reasonable interpretation should align with this intent. The concept of bonding involves connecting all metal parts and conductive surfaces in and around the pool to a common bonding grid. This grid is then connected to the grounding system. This ensures that there are no voltage differences between these parts, minimizing the risk of electric shock. The bonding grid typically consists of a network of solid copper conductors that are buried in the ground or encased in concrete. These conductors are connected to metal parts such as the pool reinforcing steel, metal fittings, ladders, diving boards, and other conductive objects. The connections are made using approved bonding connectors that are designed to withstand corrosion and maintain a low resistance connection. Grounding, on the other hand, involves connecting the electrical system to the earth. This provides a path for fault current to flow back to the source, tripping the circuit breaker and de-energizing the circuit. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, that is connected to the electrical panel. The bonding grid is connected to the grounding system, providing a path for fault current to flow to ground in the event of a fault. In the specific scenario with the boulders, it's important to consider the potential for them to become energized due to a fault. If a live wire comes into contact with the boulders, they could become energized, posing a serious shock hazard to anyone who touches them. By extending the bonding grid under the boulders, the electrical potential of the boulders is equalized with the surrounding area, reducing the risk of electric shock. The installation of the bonding grid should be done in accordance with the NEC and local codes. This includes using approved materials, making proper connections, and ensuring that the grid is properly buried or encased in concrete. It's also important to inspect the bonding grid periodically to ensure that it is in good condition and that all connections are tight and corrosion-free. When evaluating the situation, consider the likelihood of people climbing on the boulders, especially children. Pools are often used for recreation, and it's reasonable to assume that people will interact with the surrounding environment, including any rocks or structures near the pool. Even if there are signs or warnings discouraging climbing on the boulders, it's important to take a proactive approach to safety and install the bonding grid to protect against potential hazards. The authority having jurisdiction plays a crucial role in interpreting and enforcing the NEC. The AHJ has the final say on whether the bonding grid is required under the Boulders. It's advisable to consult with the AHJ to get their opinion and ensure that the installation meets their requirements. Document all decisions and communications related to the bonding grid installation. This documentation can be helpful in the event of a future inspection or if there are any questions about the installation. Include photos of the installation, diagrams of the bonding grid, and any correspondence with the AHJ. Also, keep records of all materials used and the qualifications of the electrician who performed the work. By taking these steps, one can ensure that the pool is safe for swimming and that the electrical installation meets all applicable codes and standards. Furthermore, it's always a good idea to stay up to date on the latest NEC requirements and best practices for pool electrical safety. The NEC is updated every 3 years, and there may be changes that affect the bonding and grounding requirements for pools. By staying informed, one can ensure that the pool remains safe and compliant with the latest codes. To elaborate further on the technical aspects, let's consider the materials and methods used for creating a pool bonding grid. The most common material is solid copper wire, typically number 8 American wire gauge, or AUG, or larger. The size of the wire is determined by the NEC and depends on the size and type of pool, as well as the distance to the grounding electrode. The copper wire must be insulated, and the insulation must be suitable for direct burial in the ground or encasement in concrete. The connections between the copper wire and the metal parts of the pool must be made using approved bonding connectors. These connectors are designed to provide a low resistance connection that is resistant to corrosion. There are several types of bonding connectors available, including compression connectors, set screw connectors, and exothermic weld connectors. The choice of connector depends on the specific application and the type of metal being connected. The bonding grid must be installed in a continuous loop around the pool. This loop should be located as close as possible to the pool's edge, typically within 18 inches. The copper wire is buried in the ground or encased in concrete, typically at a depth of 4 to 6 inches. The bonding grid is connected to the pool reinforcing steel at multiple points. These connections are made using bonding connectors that are attached to the rebar. The number of connections depends on the size of the pool and the spacing of the rebar. The bonding grid is also connected to any metal fittings that are within 3 feet of the pool's edge. These fittings include ladders, diving boards, handrails, and other metal parts. The connections are made using bonding connectors that are attached to the metal fittings. The bonding grid is connected to the grounding system at a single point. This connection is made using a grounding electrode conductor that is connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode conductor must be sized according to the NEC and must be installed in a continuous run from the bonding grid to the grounding electrode. The grounding electrode must be located as close as possible to the pool, typically within 5 feet. Once the bonding grid is installed, it should be tested to ensure that it is functioning properly. The test involves measuring the resistance between various points on the bonding grid. The resistance should be very low, typically less than 1 ohm. If the resistance is too high, it indicates that there is a problem with the bonding grid, such as a loose connection or a corroded conductor. Any problems should be corrected before the pool is put into service. In addition to the bonding grid, there are other electrical safety requirements that must be met for pools. These requirements include the use of ground fault circuit interrupters, or GFCIs, for all electrical outlets within 20 feet of the pool, the proper installation of underwater lighting, and the use of approved wiring methods. All electrical work on pools must be performed by a qualified electrician who is familiar with the NEC and local codes. It's also important to educate pool users about electrical safety. This includes warning them not to use electrical appliances near the pool, not to swim during thunderstorms, and to report any electrical problems to the pool operator or owner. By following these electrical safety precautions, pool users can enjoy the pool safely and avoid the risk of electric shock. NEC Table 310.15b16 provides ampacity ratings for conductors. Different wiring methods have different ampacity. Also, NEC Article 250 provides information on grounding and bonding. For example, NEC 250.122 provides information on equipment grounding conductor sizing. NEC 250.66 provides information on grounding electrode conductor sizing. NEC 300.5 pertains to underground installations. When you are working with pools, remember to consult the latest edition of the NEC and to follow all applicable local codes. It is also important to consult with a qualified electrical inspector to ensure that the installation is safe and compliant. For example, a 120-volt lighting fixture needs to be on a GFCI-protected circuit. A 240-volt pump motor must also be GFCI protected. Keep in mind the difference between grounding and bonding. Grounding helps protect the electrical system itself, while bonding helps protect people from electric shock. Therefore, a pool bonding grid serves an important safety function. Be aware of the dangers of electrical shock around water. The electricity always seeks the path of least resistance, and water is a good conductor of electricity. This means that if someone comes into contact with an energized object while they are in the water, they could receive a severe or even fatal electric shock.